Again, we're going to solve a problem, trigonometric equation. Again, we have something other than a single x or a single theta here. This time we have a fraction of an angle. And again, I'm going to use the method of substitution to solve this problem. I'm going to substitute in place of x over 3 the letter y. Now I'm going to replace y in my original equation. The sine of y is equal to positive 1/2. In this equation, I'm dealing with sine, and sine has a period of 2 pi. So as I look at the values between 0 and 2 pi that produce a positive ratio for 1/2, I notice that all students take calculus indicates to me that there will be two such angles that produce the ratio positive 1/2 for sine between 0 and 2 pi. One angle will be in quadrant 1 and the other angle will be in quadrant 2. And as I look back here at 1/2, I say I know what angle produces that ratio. It's a 30-degree angle. And another way to say a 30-degree angle is to say pi over 6. That would be this angle in quadrant 1. To get the same angle, I use the reference angle here in quadrant 2. This is pi, and pi minus pi over 6 is 5 pi over 6. So between 0 and 2 pi, for y, I have two answers. Keep in mind, that's not what I was originally asked. My original equation contained x's. And I'm going to say that this answer for y will be repeated every 2n pi, because I'm dealing with sine, and sine has a period of 2 pi. In the next step of this equation, I am going to replace my y with x over 3. So now I've got x over 3 is equal to pi over 6 plus 2n pi. Now I want to get x alone on one side of this equation, and it seems to me the best way to do that would be to multiply both sides of my equation by the number 3. As I multiply the left-hand side by the number 3, I observe that when I multiply the right-hand side by the number 3, I'm going to have to distribute that multiplication. Multiplying the left by 3, I get plain old x. When I multiply the right by 3, I get 3 pi over 6 plus 6n pi. If I reduce 3 pi over 6, I get pi over 2 plus 6n pi. That was for my first answer here, but I have a second answer, and now I'm going to work on the second answer. I'm going to replace y again with x over 3 is equal to 5 pi over 6 plus 2n pi. And again, I'm going to multiply both sides of my equation by 3. And again, I'm going to distribute that multiplication to both terms on the right side. On the left, I get x. On the right, I get 15 pi over 6 plus 6 pi. If I reduce 15 pi over 6, I get 5 pi over 2 plus 6 pi. Now again, with the problems with multiple angles, I'm going to start in, and I'm going to take this answer here and this answer here, and I'm going to replace the n's in those answers, and I should have n's in both of those answers, with numbers starting at 0. If n is equal to 0, and I use my first answer, x is equal to pi over 2 plus 0. And if I take my second answer and I replace my second answer with n being equal to 0, I get 5 pi over 2, and I notice as I stop right there that 5 pi over 2 is equal to 2.5 pi's. I was instructed to get the answers between 0 and 2 pi, and clearly right away here I'm over 2 pi. So I'm going to stop computing my answers, and I'm thinking there is only one answer to this equation, and that is when the angle is equal to 2 pi.